applying. So this is part 2 of a video lecture series on mole calculation questions. In part 1, we went through the basics of mole to mass conversions and applying the stoichiometric ratio. In part 2, we'll be exploring the nature of excess and limiting reagent questions and how we can ensure a systematic approach to always get the question right. Let's start by analyzing what an excess/limiting reagent question is. So in nature and industrial chemical reactions, it's important to note that chemicals don't react in exact proportions. You can see a key example here where there's an extra amount of the blue solution forming an extra blue puddle compared to the small yellow puddle from the yellow solution. Now in this situation, the yellow puddle is acting as the limiting reagent and the larger blue puddle is representing the excess reagent. Now if we had to talk about where the reaction is actually occurring, where the product is forming, it forms over the surface where both reactants overlap. And that is specifically this region here. So very important to note, the region where product is formed is limited by the limiting reagent. So the limiting reagent limits the product formed. The excess reagent is correspondingly shown here. And there's an extra amount of this reagent. And all the blue highlighted region does not go on to form product. It simply remains there and it's not used in our calculations hence. So it's very important to understand in all excess limiting reagent questions, we will be going after the limiting reagent as it limits and defines the mass and number of moles of product formed. Now, how do we know when we're dealing with an excess/limiting reagent question? Now, when you are given data about both reactants, you can imply that this is an excess limiting reagent question. Key example here, where we've been given data about reagent 1, which is sodium hydroxide, and reagent 2, which is sulfuric acid. So now that we know how to identify excess/limiting reagent questions, how do we approach them? Now there are 3 broad steps. Step 1 is to find the number of moles of both reagents. This will help us identify the excess and the limiting reagent. In step 2, we're going to divide the number of moles by the stoichiometric ratio of each reagent. And this will conclusively tell us what the limiting reagent is. Finally, we are going to apply the stoichiometric ratio to determine any other substances in the reaction, such as the product. Now, given we have our plan of attack, let's delve into this question. So you see an equation, straight away you would like to write the chemical formulae. So we have sodium hydroxide combining with sulfuric acid to form salt and water. This is an acid-base reaction where the sulfuric acid combines with the base sodium hydroxide. Now, in any acid-base neutralization, we always get a salt and water. The salt is always formed from the negative ion of the acid and the positive ion of the base. So in this situation, the salt is going to be sodium sulfate and water. Now, very important you include the two and you cross-multiply the valencies whenever you form a new salt. Let's include our states here. So your acid and base are generally aqueous. Your salt, if it's soluble, in this case it is due to the fact that we have a group 1 metal, it is aqueous, and the water is a liquid. Now we're yet to balance it, so let's quickly do that. Now I notice that we have a 2 sodium on the right hand side and 1 sodium on the left. So I'm going to add a 2 there. Now you also notice we have 4 hydrogen on the left and 2 hydrogens on the right. So we're going to add a 2 here. And that should be our balanced equation. Next, let's write our data under the relevant subsections. So under sodium hydroxide, we have a concentration of sodium hydroxide equaling 0.03 moles per liter. I have a volume of sodium hydroxide equaling 25 milliliters. Now I'm going to do the same thing for sulfuric acid. So the concentration is 0.02 moles per liter and the volume is 37.5 milliliters. Whenever I see C and V, I'm assuming that I'm asked to find N, because concentration is equal to the number of moles of a solution over the volume of solution in liters. And hence, the number of moles of sodium hydroxide is equal to CV. So if I input 0.03 and 25 ml, I should get a value of 0.00075 moles. Let's compare this with our number of moles of sulfuric acid using the same methodology. So inputting those values, we get the number of moles of sulfuric acid is also 0.00075 moles. So is this a balanced equation? Is there no excess/limiting reagent? Now I want you to think of any chemical reaction as a cooking recipe, where there's 2 parts of base combining with 1 part of acid to form 1 part of salt and 2 parts of water. So my 2 parts of base, I'm imagining 2 bags of base, is equivalent to 0.00075 moles per liter. My 1 bag of acid is equivalent to the same amount. Now I know I need 2 bags of base to combine with 1 bag of acid. 1 bag of base is hence 0.00075 divided by 2, which is 0.000375 moles. So 1 bag of base is much smaller than the corresponding 1 bag of acid. So what this means is that the base is the limiting reagent, as 1 part of the base is the smallest unit in this chemical reaction. And so, going back to chemical terms, the way you can always, without fail, determine the excess and limiting reagent is simply divide the mole values by the number in front of the compound. So it's stoichiometric ratio. So we're going to divide sodium hydroxide by 2, because there was a 2 in front of sodium hydroxide. We're going to divide sulfuric acid by a 1, as there was a 1 in front of sulfuric acid. And this is what step 2 is referring to when we divide the number of moles by the stoichiometric ratio in front of the reagent. So clearly we have that sodium hydroxide is the limiting reagent. So it's the yellow solution in this spill analogy. Now recall we said the limiting reagent limits the amount of product formed. So what we're going to do now is we're going to perform all calculations with respect to the limiting reagent sodium hydroxide. We're going to ignore the excess reagent sulfuric acid. So step 3 was apply the stoichiometric ratio. And that involves putting the number of moles of what you want over the number of moles of what you have and equating them to their respective ratios in front of the compound. So we want the number of moles and hence the mass of the salt, which is sodium sulfate. We have the number of moles of the limiting reagent, which is sodium hydroxide. And looking at the numbers in front of each compound, there is a 1 in front of sodium sulfate. So I'm going to put a 1 here. There is a 2 in front of sodium hydroxide. 2. So I'm going to put a 2 here. And I know the number of moles of sodium hydroxide is equal to this value here, which for accuracy's sake, I'm going to store as A. Now note, it is not A divided by 2. This 2 value here was solely used to determine the limiting reagent. It's not used in any calculations thereon after. So it's the 0.00075 that we are going to use for the rest of our calculation. And so, the number of moles of Na2SO4 is hence equal to half the number of moles of NaOH, simply by bringing this up. And that is equal to half of A, as we've stored the number of moles of NaOH as A. And hence, to find its mass, we simply have to use number of moles is equal to mass over molar mass. And hence, the mass of sodium sulfate is equal to the number of moles times the molar mass of sodium sulfate, which is equal to A over 2 times 2 times the molar mass of sodium, which is 22.99, plus sulfate, which is 1 sulfur, 32.07, plus 4 oxygen. In each oxygen is 16. And that leads us with a final answer of 0.053 grams. Is this our final answer? No. As you can see here, the lowest number of sig figs in the question is 1. And we use this value, which is an inaccurate value, hence we can only keep our answer as accurate as 1 significant figure. So our final answer is 0.05 grams. So recall, for any excess limiting reagent question, there are 3 key steps we're going to take. If we see data about both reactants to find the number of moles of both reactants, we can assume it's an excess limiting reagent question. We then, number 1, find the number of moles of both reagents. We divide the number of moles of each reagent by the number in front of that reagent to clearly identify the limiting reagent. We then simply apply stoichiometric ratio, which involves putting the number of moles of what you want over the number of moles of what you have and equating it to the respective ratios. And this is how you solve every single excess limiting reagent question. And that concludes the video.